like to come back to the idea of percent. Earlier, we learned that we can use this equation, I have it in blue, part equals percent times total, to solve percent problems. Now, notice if I take this equation and I divide both sides by total, I get another equation that says percent equals part over total. So another way of thinking about percent is it's actually a ratio of the part that you're talking about divided by the total. So let's quickly review what we learned in the past, and then we'll expand on that. So if I want to find what is 15% of 90, I'm trying to find the part. So I would take the percent, write it as a decimal, 0.15. Remember, I moved the decimal 2 places to the left. And I multiply that by the total, which is 90. That gives me the part, or an answer of 13.5. Now, if I want to find the percent, 25 is what percent of 40? We can use that same equation. 25 is the part. The unknown now is the percent. 40 is the total. To solve this equation, I would divide both sides by 40. 25 divided by 40 is 0.625. As a percentage, we move the decimal 2 places to the right, and I get 62.5%. Now, we could have skipped a step, and to find the percent, it always works to take the part, which is the 25, and divide it by the total, which is the 40, and that would give you the exact same answer. Now, we're going to take this a step further and talk about percent increase or decrease. The percent increase or decrease is still a percent, so it's part over total, but in this context, the amount of the increase or the decrease, the actual change, is the part, and the total is the original amount. And we'll see how this works through some examples. So a salary of $40,000 is increased by 4%. What is the new salary? So the first thing we have to do is find the amount of the increase. What is 4% of 40,000? To do that, we can take our 4%, write it as a decimal, and then multiply it by the 40,000. That gives me $1,600. So in this problem, this person's getting a $1,600 raise. So then the next thing we have to do is figure out, well, what is the new salary? So we'll take the 40,000, add the 1,600, and that gives me 41,600. Now, it's possible to do this problem in one step instead of two if you would like. You can take the 40,000 and multiply that by 1.04. And what that will do is the 0.04 takes care of the increase, and the 1 takes care of the fact that you get to keep your original salary. That 1.04 is of the form 1 plus r, kind of like what we learned about when we talked about exponential growth. Now, you don't have to do the problem this way. I don't think it's a bad idea to do it in 2 steps to break down what you're doing here. But if it makes sense for you to multiply by 1.04, that's great. So what about percent decrease? Well, it works almost the same way. We can do this problem as a 2-step problem. The first step is to figure out what is the decrease, or in other words, what is 15% of 20,000. So we're going to take 15%, write it as a decimal, and then multiply that by 20,000. That gives me 3,000. So the population is going to go down by 3,000. To finish, we want to figure out what is the new population. So we're going to take the 20,000 and subtract 3,000. That gives me 17,000. Now, just like in the last problem, you can do this in one step if you want. You would take the original population, 20,000, and instead of multiplying by 1 plus r, we're actually going to multiply by 1 minus r. So in this case, it would be 1 minus 0.15, or 0.85, and that gives us the exact same answer. So in percent decrease, we have to subtract the percentage. In percent increase, we add the percentage. What if we actually want to find that percent? Example 3 says shoes that cost $25 are on sale for $21. What is the percent change? Well, once again, with percent increase and decrease problems, there usually are two steps to these problems. The first thing we have to do is figure out, well, what is the change? What is the change in price? $25 minus $21 is $4. So there's a $4 change. Then we have to figure out, well, what is that change as a percent? And so this is where we're going to use the formula I gave you earlier. We take the amount of the change, and we're always going to put it over the original amount, the first value or the starting value. So in this case, that's the $25. 4 divided by 25 is 0.16, or 16%. All right, let's do one more example. A population of a country was 4 million, and now it's 5 million. What is the percent change? So the first thing we have to do is find the change in population. So 5 minus 4 is 1. This population changed by 1 million. Then to change that into a percent, we take the amount of the change, and we always put it over the original or the starting value, which in this case was 4. 1 divided by 4 is 0.25, or 25%. And that kind of makes sense. 1/4 and 25% are the exact same thing. So in example 4, the population increased by 25%.